Back. Today we're going to talk about lesson 1.3, describing quantitative data with numbers. We've already sort of been doing this, right? So as a recall, quantitative numbers are numbers, or quantitative data is data that can be described by numbers. How many pairs of shoes you have, how many states you visited, what your height is, what your weight is, those sorts of things. We have some measurements that we've been using, especially when we've been doing data displays, but we're going to look at some more in-depth statistics that we can use and how to get there both by hand and with our calculator in order to help us talk more informedly about data in terms of numbers. So let's get right into it. One that's probably familiar to you is if we talk about finding the mean. In statistics, when we have the mean, we're going to use the symbol X with a bar over the top. The way to find the mean is that's the simple average, right? So you take the sum of the data values and you divide by the number of data values. That's a simple mean. And we really need to take into consideration with mean is, it's all the values obviously, but if you have one that's really, really big or one that's really, really small, it can skew our data, right? So if, for example, I've got the salaries of employees at a company and I have one that's really an outlier out there, right? A really high salary for the CEO, for example, and you average them all together, it's going to pull up the average or the mean value. And so we really want to use this with symmetric data. So where you don't really have a ton of those outliers and you've got most concentrated around the middle. Now, the other measurement that we can use is median. And as we've discussed, that's going to be the middle point of a distribution. And this measurement we want to use with skewed data because it's not affected by those outliers the way that the mean would be. That's mean and median. The second piece that we're going to talk about today is the concept of variability. When we talked about variability in the last video, we really only had one measurement for it, and that was the range. And range is found by taking the max and subtracting the minimum value. So the max minus the min is going to give us the variability. There's another measurement that we're going to talk about. I'm going to give you the formula, and the formula looks really daunting, but it's really not that complicated. In practice, it's just kind of repetitive with what you do. So the other measurement for variability that we're going to use, and this is one we're going to use more often, is standard deviation. Standard deviation is found by taking the square root of the sum, so we're going to add all of them together, of x minus the mean squared. That's not the full formula, but kind of hear me out here. Basically what we're going to do is we're going to take the average distance from the mean for every single value. So that involves taking each individual data point, and that's going to be our x sub I, so each individual data point, and subtracting it from the mean. For example, if I got a score of 90 on a test and the average was an 85, I do 90 minus 85. Well, my score was 5 points above the mean. Then I'm going to square that to get 25. And then I'm going to take the square root of that. So the average distance is mean, or the average distance is 5, but that's only with one data point. Standard deviation takes into account how much everything typically varies from the mean, and the formula completes itself in this way. We divide the total of all those things that we added together, which is each individual difference squared, added together, divide by the number of values minus 1, and then we're going to take the square root of that whole thing. Like I said, in practice, it's a little bit more repetitive, and we're actually going to use our calculator to figure this out in most cases. But the most important part about standard deviation is understanding the context. What I'm going to write here is a sentence. It's going to have a few blanks in it that you'll fill in per the prompt of the problem. So the blank typically varies from the mean of blank by blank. Here's what I mean. The context. In my case of that problem with the test scores, so each individual test score for an AP student typically varies from the mean of, and then I'm going to put what the mean is in there, of 85 by, and then here's going to go my standard deviation. So you're going to fill in this sentence with the information specifically from the problem, what is the context of the problem, and then what you calculated as the mean and what you calculated as the standard deviation. Obviously, all of these things are affected by what the data in the problem actually is. And it's important to consider a couple of things when we're talking about these individual measurements. So, something to consider. Mean and standard deviation are greatly affected by outliers. What we would call them is non-resistant. So they are non-resistant to outliers, meaning if you have an outlier in a data set, your mean and your standard deviation are going to be pulled in the direction of that outlier. The other thing that we need to make sure is that we use median for skewed data, or if we have outliers. Okay? And then for symmetric data, we're going to use mean. That's the basic gist of this. A lot of these calculations are going to be able to be found with your calculator. We're going to talk about that in just a minute. But really, it's the interpretation. One of the main things that we're going to pull out of this lesson is being able to apply this context here. Almost assuredly, they will ask you this on the AP exam. And throughout this course, we're going to talk about it heavily, like what does it mean to find the standard deviation? Let's look at an example. Some students purchased pumpkins for a carving contest. Before the contest began, they weighed the pumpkins. The weights of the pumpkins in pounds are shown here along with a histogram of the data. So here is the weight of all of our pumpkins. I'd like for you to pause here and do this, check your understanding, try it on your own, and when we come back, you can unpause the video and I'll show you the explanation. Okay, here's our data for our pumpkins. When we calculate the mean weight of the pumpkins, that's going to be X bar or mean. Remember, mean is denoted X bar in statistics. We simply add all the weights of the pumpkins together, all the way up to 31.0 and 33.0. And we're going to divide by the total number of pumpkins, which in this case is 23, to give us a mean weight of 9.935 pounds. That's if we considered everything together and divided by the total number of pumpkins. To find the median weight of the pumpkins, obviously we would have to put the weights in order. And find the 12th weight. Why the 12th weight? Well, that's going to be the middle one. So you can, there's the cross-out method, right, where you'd cross out one from each end. Well, you can also do it mathematically, especially if you have a really large data set. The 12th weight would be the middle. So in this case, the median weight would be equal to 6.6 pounds. Notice the difference here. And obviously what we see with our data is we have some really small values like a 3.6, a 2.0, a 6.0, a 3.4, but we also have some really big data values, right? There's 31 and there's 33. That's going to be what is asked in the next question here, but notice this really big, relatively big bump out here. What is that going to do for our data set, and what kind of measurements might we use if we have a data set like this? Those are the questions that we're going to be asking in statistics. Question number 3 addresses just this. Would you use the mean or the median to summarize the typical weight of a pumpkin in this contest? Explain. Well, you can see we have some outliers. So I would use median. Because we have a couple of outliers. Not only that, but the distribution is skewed. And those potential outliers, I'm going to denote them. I'm going to say we have potential outliers at 31 and 33. Now notice, kind of like I was pointing out before, when we have these outliers, or these potential outliers here, and we have this skew, that mean weight is pulled in this direction. And what I mean by that is, if our median is 6.6 and our skew is to the right, our mean gets pulled to the right, meaning it's greater than our median. So the mean is going to follow the skew in this case. That's the basic gist of section 1.3, describing quantitative data with numbers. Now, let me give you a little bit of a tidbit here. We can also do these calculations on our calculator. So let's say you wanted to find your standard deviation of your data set here. And actually, your calculator can find all these statistics. It can find mean, median, mode. It can find Q1, Q3. It's got a lot of different things that can happen here. These are the calculator functions. So on a TI 83 or a TI 84, you're going to go to Stat, and you're going to hit Edit. And in L1, you're going to put your data. So all 23 data points. After you get your data in, you're going to go back to Stat, and you're going to go to the Calculate menu, so Stat Calc. You're going to see a laundry list of different functions that you can do. The one that we're going to be concerned with in this video, and for these basic calculations, such as mean, median, mode, Q1, Q3, is going to be our one var stats, one variable statistics. That's going to spit out an X bar, a standard deviation, different kinds of the total number of values that you have, the sum of those values, and those sorts of things. That's going to be a quick way to find a lot of different measurements for quantitative data. So keep that in mind, write that down, and we're going to do that quite a bit in this class. All right, guys, that's the basics of describing quantitative data with numbers. And if you have any questions, please let me know, but we'll see you next time.